Saxon's Calculus Lesson 62 is about maximization and minimization problems. There is a lot of information on page 309, which reminds us in bold words that we can have an absolute maximum or minimum value of a function when we have a set interval such as like from 1 to 5. The absolute maximum or minimum value is sometimes called the global maximum or global minimum value. So our search for an absolute maximum or minimum value of a function on an interval begins by finding all of the critical numbers of the function on the interval. And to do so, I want to remember that the area can be found by let me give you this equation, negative 3x squared plus 6x plus 2, for example, by following this formula where we had negative b over top of the exponent of the highest one multiplying with its coefficient. So to do that for this example, that would give us negative 6, that's the b, over the highest exponent, which is 2, and its coefficient, which is negative 3. When I simplify that, then I get positive 1 because this is negative 6 over negative 6, so positive 1. Then the maximum value of this function occurs at the 1 because that's that central core number. So then when I plug in 1 to the equation, we would get negative 3, 1 squared plus, I'm just going to write that as 6 plus 2. 1 squared is 1, negative 3 plus 6 is 3, plus 2 is 5. So this original equation was a squared with a y equals or plane something or other. So I know it's a parabola, and I know that the vertex point then should be beginning at 1, 5. It is overall a negative, so the parabola would be opening down. So then that means my 1 is a maximum value. All right, then at the bottom of 309, they give you these 3 statements. The graph of a polynomial function is a smooth curve, no gaps or jumps in it. It has no corners and no vertical tangents. Now, horizontal this way, vertical this way. So there's no tangents going up or down because you're looking at a parabola. There are no critical numbers for this function that are caused by the failure of the derivative to exist. We have a derivative, there is a slope. Step 2, no domain was specified. So we assume that the domain is the set of all real numbers. That makes sense. I could plug in any x value that I wanted. The set of real numbers does not have endpoints, right? Because this keeps going forever and ever and ever. So there are no endpoint critical numbers. So if it did have a beginning or an end spot, then those would also act as critical numbers. So far we only have the 1. The only other critical numbers are those numbers for which the first derivative gives us 0. So let's derive this original equation and make that negative 6x plus 6 set equal to 0. Divide everything by 6. That basically gives us negative x equals, now went to a positive 1. I'm going to move it over, make it negative 1. So x equals 1. Oh, look, that's the same thing I had before. First derivative and set it equal to 0. Then we solve, x equals the 1. So we find that we have only one critical number, and that was, of course, 1 at the point 1, 5. And now they also want to do a second derivative test just to confirm what it's doing. So the second derivative test would take us to negative 6. And since that's negative, if we remember our first one was positive, then negative. No, doesn't matter. The second derivative was negative, so it's making the frowny face, so it is still a maximum point. They're just doing the same thing, showing you how all of your tests get you to the same conclusion. So now, in example 1, we have a word problem. Mr. Wallen has 100 yards of fence. He wants to form a rectangular field enclosed on 3 sides by the fence and on 1 side by a river. So if I have a river and I'm fencing 3 sides and all of that together equals 100, if I call this side X, then this side is X. Then that means that the length left is 100 minus the 2 X's that we just used. Okay, wants to fence on 1 side by a river whose banks are straight. Well, I curved it a little bit. You get the idea. Find the dimensions of the field which can be enclosed by the fence that has the greatest area. So we want to find the area of our rectangle, which would be 100 minus 2x times the x, length times width, gives me the area, equals the A for area. So if I distribute that, then A equals 100x minus 2x squared. Then I can derive it, which will give me derivative of the area equals sorry, I was having a split moment there, equals 100. I was debating if I wanted to write it in the other order, minus 4x, and I think it's fine to write it this way. Then I need to set that area equal to 0 to find my maximum, so I'm just going to write the 0 here. So negative 4x equals negative 100, x, that's going to go to a positive 25. So the function has one value at A, they go ahead and derive it a second time just to confirm. So that was here. So that would go to, that would drop off. Negative 4 would be the second derivative. Then if I plug in, just a second, why did I do the second derivative? I got a negative. Yes, that's telling me that then that is so my equation is giving me the maximum. So let's plug the 25 in to find, does it want the maximum area or the, yes, the greatest area. Yes, yes, yes. Okay, so we're going to plug the 25 in. So 25 squared, wait, is that the right one? Yes, 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 yes. I'm doing the derivative one here, and I want the original area. This is the one where I distributed. It doesn't matter, either one of these. Oh my goodness gracious. Okay, so then 20, I'm wondering if it's easier, no, because I still have to multiply by 25 again. 25 squared, I can't do in my head, times 2, and then 2,500 minus that answer should be 1,250 dimensions, yards and squared. And hopefully on your calculator, plugging into either one of these should get you to here. I just struggled to do it in my head. Now, example 2 says, find 2 positive numbers whose sum is 8. So I have an x plus a y equals 8, and whose product is a maximum. So I know that x times y is giving me the area, and they want it to be the maximum area possible. So I need to solve for either the x or the y in the first equation. Let's solve for the y. So y equals 8 minus x. Plugging in, that gives me x multiplying with 8 minus x is the area. Distribute 8x minus x squared equals a. To derive it then gives me the maximum, so the derivative of a equals 8 minus 2x. Second derivative takes me to -2, which means it is the max value. That's confirmed. Then set this equal to 0 to solve. So -2x equals -8, x equals 4. And then plug your 4 back in. 8 minus 4 is 4. 4 times 4 is 16. Just a second. Does it want the main area? No, it wants the 2. Okay, well, it would be 16 as the area. However, they're looking for the 2 numbers. So if x is 4, y is, also 4. So the 2 numbers are 4s. 2 positive numbers, sum is, yeah, that's all they're looking for there, those 2. Then example 3. We would like to make an open cardboard box by cutting squares that are x inches on each side from the corner. Okay, so let's draw a, I think it said it was a square, didn't it? Nope, not square. Okay, I drew that right. So we are cutting off corners here, 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 and here, and each of those were x by x. And then it said, okay, the longer one is 15, the shorter one is 12 inches. I'll just put the inches symbol there so we have it to remind us. Now, what else does it tell us? Folding up the edges, find the value of x that will result in the largest possible volume, and then find the volume of the box. Okay, so volume is going to be area of the base times the height. To get the area of the base, I basically need this part in here, and so that is going to be the 15 minus 2 x's for that part, and then the width will be 12 minus 2 x's, and then the height would be the x that was going upward then if you fold it. So that's the dimensions of the box. So if we work that out, we would get that the volume is, 15 times 12. That's their whole number without an x. Oh, yes, that is the 180. Okay, then 15 times -2x, -30x, -2x times 12, -24x. Negative times negative is positive, and then that is 2 times 2 is 4x squared. And all of that is still multiplying with x from the outside. So our volume is now 180x minus, just a second, let's put those together. 54x squared plus 4x cubed. Now that should be the volume. Yes. All right, so then we need to derive that. So the derivative for the volume is 180 minus 2 times 54, 108x plus 12x squared. Okay, now deriving a second time just to make sure that we're getting max. That drops off. That's -108 plus 24x set equal to 0. Cramming that in there. So that's going to make it positive divided by, so that's a positive answer. So that should mean that would be minimum. When that happens, I realize that I actually have up to, because this was originally cubed as the highest, I can have up to 2 curves. So I may have 2 answers. One of them will probably work in the second derivative and the second one won't. It'll be a minimum value, not a maximum value. So the test is telling me I've got the possibility of both. So let's go back to this original and set it, well, I can set it equal to 0. My problem is I can't factor that, although 12, I could reduce all of them, they're even, but I doubt that even that's going to help me factor this. So probably my best bet is to throw it into the quadratic equation. Let me see, the book did that. It went ahead and reduced it. Okay, let's do that then. At least that'll take me down to, should be x squared. So I can pull my a, b, and c. Yes, okay, so that's going to be x squared minus 9x plus 15 is being set equal to 0. So my b is -9, so plug in 9 plus or minus the square root of 9 squared, 81, minus 4 times a, that's 1, so that's 4 times 15, which is 60, over top of 2 times a, so 2, because 2 times 1, then 81 minus 60, 21. Square root of 21 is going to be a decimal on the calculator. And then make sure you do 9 plus that decimal divided by 2 and 9 minus that decimal divided by 2. So what I'm seeing here is that I'm getting the answers 2.21 and 6.79. So then I want to plug those into my second derivative and see what happens. So when I plug in 2.21, I get a negative answer. When I plug in 6.79, I get a positive answer. So since a positive answer means I'm making concave up, and a negative answer means I'm making concave down, this one is my max point. So the 2.21 is the maximum value. Now that I know that, I will plug it back into the original volume. Either one of those is going to be fine. I would probably do this one. So 2.21 cubed times 4, 2.21 squared times 54, 2.21 times 180. So that's definitely all calculator work to get, and you're looking for something pretty close to 177.23 inches cubed because we were doing volume.